All right, there we go. So we're going to talk about some situations where we have similar triangles happening because of something special in the figure, okay? And there's also some different ways we can set up the proportions as opposed to looking at specifically the two triangles. So this first theorem right here, okay, have we seen this before where we have a triangle with parallel lines inside? Okay, well, these are parallel lines, okay, and then yeah, we can think of these as two transversals and we have a shared side. So yes, we can draw the two separate triangles and we can create proportions, but this also works in a way where we can put RT over TQ equal to the ratio of RU over US. So let me give you kind of some context there. Like, let's say that this is 6 and this is 4. Okay, and I'm saying like this right here is 6 and this right here is 4. So what's the whole RQ? 10. Okay, well, if these are parallel lines, we wouldn't necessarily have to worry about that. Okay, if this was 3 and this was 2, we could say, okay, 6 over 4 is equal to 3 over 2. Is that true? Okay, that is true. Okay, so we can set up proportions by using those parallel lines that cut the triangle. Okay, so we're going to draw a picture and we're going to use that to help us. Are you ready? So I'm going to have you draw this picture right here. So since we have these two parallel lines in this triangle, what we can do is we can say, okay, we can take these two right here and make a ratio 9 over x, and that better be equal to the ratio we make on the other side, 12 over x plus 1. See how that works? Okay. Now, I know that you guys still are a little bit uncomfortable with proportions. I don't know why that is. Okay. But when we set up a proportion, we're going to cross multiply. Okay. So we're going to take 12 times x, which would give us 12x. But what happens when we take 9 times x plus 1? 9x plus 9. Because that has to multiply to both of them. Yeah. Okay. So we have 3x equals 9, aka x equals 3. Okay. Now this theorem has a converse saying, hey, if we have proportions, if we have our, if these sides are split up proportionally, then it's gonna tell us what about these two lines? Then they're parallel, okay? So it's like the backwards. So up here, if these are parallel, then we know we have proportions, okay? Down here, if this is proportional, then that means these two lines are parallel, okay? We're probably just more gonna focus on that first theorem. Okay. Okay, let's go ahead and turn. It's not a turn of the page, it's just glance over at the next page. Okay, so here, ooh, what is going on in this picture? We have three parallel lines. Do you see that? We have three parallel lines and two transversals. And what is happening? These parallel lines are dividing the transversals proportionally. So what we're going to be able to do is we're going to be able to take this piece right here, divided by this piece right here, and it should be the same ratio as if we were to take this piece divided by this piece.
W divided by WY would equal.
And look at this, it says exactly that right there. Okay. Right? All right, so what we're gonna do is we're gonna draw a picture. You ready? Okay, don't you draw that picture.
Why is it so silent?
Yeah. So they go with like 120 is labeled for like this segment. The segments. Okay. All right. So if these three angles are congruent, what is that? What else is that telling us? Ooh, thank you. The lines are parallel. Okay. And if we have three parallel lines with two transversals, then our parallel lines are cutting our transversals proportionally. Okay. So Braden, how do you think we should set up our proportion? $120 over. Nope, 120 over. Yeah. Equals 150 over 300. Okay. It's basically like telling you what the fractions are, right? Like, look at it. There's even like the parallel line is a fraction bar. Right? Okay. Oof. Cross multiply. We have 150x equals 36,000, which means x is 240. We're not calling it the butterfly method, it's called cross multiply.
It's just like a circle instead of lines.
We're not talking about butterflies.
Her line is in a way that it is circle. Slash wall.
Okay, our last theorem, the triangle bisector theorem. If we have a ray that bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the other two sides. What? Okay, so here we go. We have an angle bisector. That's this guy. Okay, notice how these two angles are congruent. Okay, so what's happening? It is breaking up this side into two pieces. And then if you look at the other side, we can set up a proportion AD over DB equals CA over CB. Or what I'm probably going to have you do, I'm going to probably have you set up a proportion AD over AC equals DB over AC. Okay. This is going to be a ratio. This is going to be a ratio, and they're going to be equal.
So we can only do these if we know that there's some.
Well, this theorem says angle bisector. So if you have an angle bisector, this theorem is going to hold. Okay. What?
I guess.
We are all about the butterflies today. Okay, so draw this picture. We'll do an example. I'll tell you what I mean here.
I love butterflies. What are you choosing?
Okay, so what we can do here.
Together one.
It's the theory that everything you do in a time will result in the altercation of everything else in the future.
Yeah.
Okay, are you good if we go over this?
Yes.
Okay, so what we can do is we can say, okay, 13 over 5 equals x over 2.3, okay? Why can we do this? We have an angle bisector right here. So this segment is splitting this side to be proportional with our other two sides, okay? So now if we cross multiply, we get 5x equals,
What do you think about this? 29.
Yeah, 29.9.
can I tell you a secret? Never mind. All right, so what's x?
X is like 5.99 or something.
5.98?
Yeah.
Okay. Okay, so this is what we're gonna do. You are going to, okay, circle with me. You're gonna do number 1. Then you're gonna turn the page and do number 3. Nope. You're gonna do 5, 6, 7. And you're gonna do number 8. Yeah.
Is this just practice or is this?
This is in class practice. This is in class practice. Are you complaining? Okay. Hey, Brayden, can you tell me how you set up number 1?
Number 1?
Yeah.
Oh, so the Alex told me I should cross multiply, but I just tried to scale factor. I divided 10 by 5,
Okay.
and then like that's 1 over 2, and
Okay.
then half of 6 is 3.
But he told you to say 10 over 5 equals 6 over mystery number.
Yeah. Well, because I asked.
But you got x equals 3.
Yeah.
Or that side equals 3.
Yeah.
Okay. Beautiful. Do you agree that that is 3 right here?
Yes.
Alexa, you okay with 3? Yeah. Okay. Great. Ben, tell us what you did in number 3.
I did 3 cross multiply 4 over 5 and it equals 15 equals 16, which is not true because 15 equals 16.
It's true. Okay. So A, B, and X, Y are not parallel here. Okay. All right. Now here, UV over UW equals XY over Clark. What's the, sorry, pardon me,
XC.
XZ. Okay.
Basically like figuring out a pattern.
Yep. XY over YZ equals Harvey. What over VW?
UV, no,
Yeah.
UV.
UV. Good. All right. WU over WV equals what over ZY, Sam? Good. Okay. Don't have to worry about those. All right. Now,
It was ZX over ZY. Could you also say XZ over ZY?
I probably want to be too picky about it, but technically, since we said WU, then ZX would correspond to that. Okay. Okay. All right. Nora, how'd you set up number 8?
9 over X.
Awesome. And so when we cross multiply, what do we get for X? So X equals 3. Beautiful. Now I want you to look at number 9. Okay, we're gonna do number 9 together, and then I'll give you your homework, okay? In number 9, we have the same thing happening, right? So I can put 9 over B. What do we do for our second fraction? So 6.75 over what?
If they bisect, aren't they supposed to be similar?
Yeah, but how long is this side right here? Nope.
7.
Nope. We don't know how long it is.
Looks like
4.
6. 5 and 9.
Yeah, it looks like 6.
So, what'd you say? Minus.
B.
Yes. This is 14 minus B. If we know that this segment is B and the whole thing is 14, then this cute little guy is 14 minus B. So 6.75 B equals, what's 9 times 14?
126.
So 126 minus 9B. Right? So if I add, so we have 15.75B equals 126. B's and 6's look too much like each other right now.
And also 9.
I did 12B on
This is 126 though, right? Okay, and then I added 9B. So now if we divide by 15.75, B is, let me try that again.
I got this one.
I'm thinking it's gonna be positive, my dear, since it's a, length.
It is an 8.
I'm gonna let Alexa confirm that. Okay.
I made it. Wow.
Oh, it's 8.
I think it's 8.
Got it. Okay, so in your packets, page 11 is your homework.